All right, guys, so with this problem, it's asking us to take a look at these balanced chemical equations and then to sort out what type of equation it is. So at this point, you've got some practice writing equations, and so now we want to just make sure that you can identify the different types of equations that there are. All right, so the first thing we see is CH2H4 gets together with oxygen, and it forms carbon dioxide and water. You should see fuel plus oxygen equals carbon dioxide and water. You should say combustion. This is a type of redox reaction, and that specific type of redox reaction is combustion. Okay, so what do we have next? We have HCl plus strontium hydroxide. In this case, you should recognize that strontium hydroxide is a base and that HCl is an acid. We form a salt and water as the products. So you should be saying to yourself, this is acid base. An acid base reaction is a type of double displacement reaction. It's a very specific type involving an acid and a base. All right, what about the next one? How are you going to sort out this one? In this case, you've gotten two reactants that form one product. So in this case, we've got two things that are forming two species that form one species. So this is a combination reaction, or we also call it synthesis. All right, let's see what we got going on over on this next one. It looks pretty complicated. Well, you gotta be able to identify the types of compounds. And if you can identify the types of compounds, then you're in good shape, even if they're complicated. Look, here's some water. So I've got water and some other type of ionic compound that forms. So what does that mean? It seems like to me that means that maybe we're dealing with a double displacement reaction. And if it forms a water, maybe it's an acid-base reaction. And look here, we have H2SO4, that's sulfuric acid, and we have aluminum hydroxide. Anything with hydroxide in it is a base. So again, we've got acid base reaction here. Okay, what about the next guy? In this case, it looks like I have one reactant and it forms two products. So I have one species going into two species. And so this is a decomposition reaction. So decomposition is when one thing reacts and forms multiple other products. Or briefly, the number of products are more than the number of reactants. Okay, well, what do I got in the next one? Well, it looks like a pretty complicated reaction, but I want to point out one thing. I have some isolated elements in the reaction. And the isolated elements that are in the reaction switch throughout the course of the reaction. So this is an example of a single displacement reaction. It's not a double displacement. They're not swapping partners, but the lead and the boron do swap. So only one thing is swapping. And so this is single displacement. All right, and so the last one is very classic. I've got iron and bromine, and they get together. And I have lithium and nitrate, and they get together. So I have one thing swapping there and another thing swapping there. So both pairs of ions swap places. So this is a double displacement. Okay, that's all there is to it.